Okay guys, are you ready to get started? Let's get started coding our Lego toolkit here. So I'm actually going to start a completely new file. We're going to do this from scratch. I'm just going to call this lego.py. You can call it whatever you want. Now we're going to rewrite all this code from scratch because I want this to be a good learning experience for everyone. The only exception to that is I'm going to copy this code over right here because it doesn't add a lot of value for you guys to manually type this out. But I do want to talk through this for the new people that are learning Python. So let's look at this data type real quick. We have what looks like a list in Python. There's a couple different ways to represent things that you can think of as a list in Python. And two of the most basic types are what we call a list and what we call a tuple. So a list is normally formed in the form of square brackets like this. For example, I could say my list equals 1, 2, 3. And that would be a list object. The type in Python is list. You can actually type the word list with parentheses like this. That's an actual built-in type. Another type is called a tuple. That's also a built-in type that you can see here. And a tuple is formed with parentheses, 1, 2, 3, and I could do that. And both of these are very similar, except the main difference is the tuple object is immutable, meaning it cannot be changed. So, for example, I could do for x in my list. This will create a for loop and iterate over that, print x. And if I run this, I'm going to get 1, 2, 3 as an output. Move this over a little bit. But I could do the exact same thing for my tuple. So they're both iterable objects. They both can be treated just like a list, 1, 2, 3. But the difference is what I can't do is I can't say, for example, for x in my tuple, or let's do this. What I can't do is iterate over the range. So for I in range length of my tuple I plus equals 1. So if I wanted to add 1 to each of those values and then print that, it's not going to work. And why? Tuple object does not support item assignment. What that means is that a tuple object cannot be modified after it's created. Notice though that if I used a list, that this would work just fine. Oh, I have to save it and then run it. Oh, I'm still calling my tuple here, sorry. So my list. So I iterate over my list and then I can modify it and print it out. 2, 3, 4. So you can see the difference. That's the main difference. So let's look at this Lego data type. So these are our Lego block color objects, basically. Let's look at this. What we have is a tuple. All of these are tuples. So we have a tuple for white, a tuple for brick yellow. And inside of each of these tuples, we have an integer, we have a string, and then we have another tuple. So this is a tuple inside of a tuple. And this default color is RGB. This is also a tuple, you can see. So we actually have a tuple of all these objects. And each of these objects is a tuple of an integer, a string, and then another tuple. And this tuple is a tuple of integers that represent R, G, and B. So red, green, blue colors. So one of the other interesting properties of the tuple is we can actually combine different data types in the tuple. So we have an integer, a string, and a tuple. These are all different data types, but they can be combined into one object. Okay? So go ahead and play with that a little bit. If you're new to Python, get comfortable with the tuple object and how you can basically create a tuple using the round parentheses. You can mix data types. And go ahead and add your colors just like I did here. Now you won't have to type them all in one by one. It would be good practice to do a little bit of typing. but you can also copy this right out of the Git repository that I'll make a comment about. So why do we have this data type set up like this, where we have an integer, a name, and a RGB? Well, we're going to want to use this in our code when we get to the next video. So just to illustrate how useful this type of a data structure is in Python, what I can do is I can say for color in, and what did I call this? Default color. So these are my default colors. So for each color and default color, I can do print, and I will do F with a F with a quote mark here. So this is a special type of string. This is called a formatted string. So this will allow me to add variables inside of it. So I can say color number, and I can do color 0. So this will access the 0th position of the object. So each of these objects will be extracted. I'm going to take the 0th object and get the color's number out and put it in here. I can say color number, I can say color name, and I can do the same here. So I can say give me the first index. Remember, indexing starts at 0 in Python, so 0, 1, so I'll get the name. And then finally I'll get the RGB value with the next. And I can say color, or I can say RGB, and I'll put in color 2, and I'll save this. So for each of these, I'm going to print this out. Let's run this and see what we get. And just like that, we're able to access all of the data. We're able to get a color number, a name, and an RGB value. So that shows that why we use this type of data structure to represent our data. Now, could we do it in a different way? Could we add or remove or change this? Yes. This is just one way to do it. But by combining our data in a sensical manner like this, we can then access this in the rest of our code in a very clean way. We can access the color values, and then later when we want to tell the user, here's the type of block that should go in each location, we'll not just have a color for it, which is hard to know. It's hard to tell someone, give me a 24, 158, and 159. You want to say, give me the bright bluish green. But even that might be a little confusing. So you might say, give me bright bluish green. By the way, that's Lego block color number 107, and they'll be able to get all that information. Okay, so that's the first step in our code, is creating a system for categorizing our colors. So start with this, get this set up, and then we'll move to the next video where we start creating our functions to actually calculate our colors.